All right, let's get right into it. We're going to talk about a concept that I promise you is one of the biggest keys to unlocking that next level in your programming career. We're talking about Big O notation.
So, what do you think it is? What's that one thing that really makes the difference?
And look, you might be thinking, oh, it's knowing a ton of different programming languages, right? But nope, that's actually not it.
It's the ability to really, truly think about how your code performs. And the way the pros do that, well, that's by understanding Big O notation.
Right, this is the real senior developer skill we're talking about. It's like having a superpower. You can look at code and just know how it's going to behave under pressure without even having to run it.
And that superpower? It's all about understanding Big O notation. Now, you can read the official definition right there, but I want you to focus on just two words: scales and grows.
And here's the thing that trips a lot of people up. Big O is not about speed, it's not about measuring with a stopwatch. It's about something way more critical for building real-world applications. Yeah, this slide nails it. Speed is all about the right now. How fast is my code with just 10 things? But scalability, that's the real question. What happens when we throw 10 times million things at it? Senior devs, they live in that 10 million item world.
Okay, to really get this, let's just forget about code for a second. We're going to use an analogy that I think you'll get right away, an old-school phone book.
First up, we have the holy grail, the absolute best-case scenario. O of 1. We call this constant time. So, in our phone book world, your job is to find the very first name. That's it. Now think about it. Does it matter if that phone book is for a tiny village or for New York City? Nope. You just open to the first page, point, and you're done. The effort is constant. In code, it's the same thing, like getting the first item from an array. The computer doesn't care if there are 10 items or 10 million. It's one step. Boom. That's O1.
All right, next on our list is ON, or linear time. And this is where things start to get a little more interesting. Okay, new task. Now you have to find every single person in the book named Smith. How do you do it? Well, you have no choice, right? You have to start at A and read every single entry until you get to Z. Now, if that phone book suddenly doubles in size, guess what? Your work just doubled. That direct one-to-one relationship is why we call it linear. In code, this is your classic for loop. The bigger the n, the input, the longer it takes. Simple as that.
And now, the one you really need to be careful of. This is ON squared, or quadratic time. This is the one that can sneak up on you and bring your beautiful app to its knees.
So imagine this crazy task. Find out if there are any duplicate names in the entire phone book. Oh, you'd have to take the first name and then compare it to every other name. Then you take the second name and compare it to every other name. You see where this is going? The work doesn't just grow, it explodes. And the code equivalent? Oh yeah, it's that dreaded nested loop, a loop inside of another loop. That's a classic O of n squared problem.
Okay, so the phone book analogy is awesome for getting the concept. But let's see what this actually looks like in the real world.
And wow, this graph says it all, doesn't it? Look at O of 1 over there. It's just a flat line. It doesn't care how much data you throw at it. Then you have O of n in the middle, growing in a nice, predictable straight line. But then look at O of n squared. It just goes to the moon. That vertical climb, that's your app grinding to a halt when the data starts piling up.
So let's just quickly recap. O of 1, constant time. That's your gold standard. Excellent scalability. O of n, linear time. Totally fine. You're going to see it all the time. But O of n squared, quadratic time. That's where you get into trouble. That is a scalability nightmare. When you see it laid out like this, it's pretty obvious which one you want to avoid, right?
So, be honest. Have you ever been there? You write some code, it works perfectly on your machine with like 10 pieces of data. But then you push it to production and it just crawls.
We'd love to hear about it. Tell us in the comments, what was the code doing? And now that you know a little more about Big O, do you have a theory on what was going on? Maybe a sneaky O of n squared in there?
And this is really the whole point. The power of Big O isn't just about fixing slow code that you've already written. It's about something much more powerful.
Honestly, this is the key takeaway for the whole thing. Understanding Big O is like having a crystal ball for your code. You can look at 2 different ways to solve a problem and predict with almost total certainty which one is going to crash and burn when it hits 1 million users.
And at the end of the day, that's what we're all trying to do, right? Build solid professional apps that can handle anything. And that kind of thinking, that scalability mindset, has to start from line 1.
Look, getting a handle on Big O is a massive leap forward, but it's just one of the essential concepts you need to really level up your skills.
So, if this explainer helped click things into place for you, you're going to want to stick around. Make sure you're subscribed, and we'll catch you on the next one.